Yeah, so this next part is, so we understand how to read in data. We know how to assign that to a variable. Now, how do we start, taking data out of our data frame and then running analysis? And so the first thing I wanted to show was just some kind of overview functions of how we can examine the shape and kind of like layout of our data frame. And so in the breakout session, I had you do nrow and ncall. There's also another function that we're showing here, which is dim, which actually generates both the number of rows and the number of columns as a group of values. And we'll talk about this in a following component. And so you notice here, we took at the dimensions for the actual data frame, or the variable that you assigned your data frame. We notice we have 20 rows and 4 columns for this example. Now, this is just example data. So you may be running data that might be thousands upon thousands of observations long, and you don't want to output all of that to the console. And so this is where head and tail come into play. And so if you think about your data frame as an object, what head is doing is taking the first part of that data frame, and then conversely, tail is taking that last part of the data frame. So it's just taking the first 6 rows by default, and then tail conversely is taking the last 6 rows by default. Now, if we want to, we can get a summary of what each one of those columns are. So I hit summary with our value, and you notice we get an output that is determined by the number of columns that we have for our data frame. And if you look at this, you notice that this summary is a little bit different for each one of the columns. So you notice that sample and location. So again, when we're out in the field and we're recording this, these might be words, this might be text, right? That's going to have a different representation in R as opposed to something like numbers. So here we have this summary, which is just telling us that there's 20 of these samples, 20 of these locations. We have this character class. We'll talk about that in a second. And then we also have ear diameter and ear height. And you notice that, oh, if you've never seen this before, you can start to see, oh, this might look like summary statistics, where we're getting an average for our ear height, or ear diameter, and we're getting an average for our ear height, and then also some quartile components to our summary. Like when we're recording this data out in the field, all of these data have different representations. And so in R, there's 3 primary types of data. 2 we talked about today. Next session, we'll talk about the third one a little bit more. So, in R, we call these character type objects. So this is just text, like your name, a sample ID, a location. And then you also have numeric. So this would be like a measurement, like the height of a plant. How many bushels per acre were you able to generate for a field? Things like that. And so this can be whole numbers, and these can be numbers with decimal points. And so with that being said, we can start to, you notice a data frame is just a collection of objects, right? And we can start pulling things out. And so we have this next session where we start talking about functions where we can access data. So like all data frames, they have headers, right? So if we want to just understand what the actual headers of our column or the actual column names are for our data frame, we have this call names function. We'll run that with Control Enter. And we notice we get a collection of values that's dependent on the number of columns within our data frame. And these are just the headers or the descriptors of our data frame that we can pull out. Now, since data frames have both rows and columns, we can start accessing data based off of how we represent the data, or like how we want to approach the data. And so here I have just a very graphical representation of our data frame. So remember, we have column names, and then we have rows. So we have data going this way, and then we have columns. So data going up and down, right? And so when you think about this, you think of it like a grid, right? So you have data flowing in 2 directions. And so we have essentially 2 dimensions to our data, similar to like a matrix in math. So to do that, there's a lot of different ways that we can access this data. And so one of the probably most straightforward way is using this square bracket operator. And so to represent that in our data frame, we just take our data frame variable and we specify an open and close square bracket. And so you can kind of think of that like a function, right? And this function takes 2 parameters. One is a specific row number, And then another one is a column number or column name that we'll talk about a little bit later. And so if I was to, take my data and I want to specify the rows, that's the first parameter. We're pulling out this row. We're pulling out the second row of data, right? So we specify that with the number 2. So it's the second row. Conversely, we can do that with, and so just to show that, we have myDF, we pull out one row. So this is row 2. Conversely, we can do that with columns. So we can pull out a range or a collection of values for column number 3. We pull that and we get some numbers, right? And so this represents the third column. So this is ear diameter. And then we can combine both of these together. So if we want to extract one particular value, instead of just the full row and full column, we can get that intersect by specifying the row number and the column number. And so just to show that, I'm just showing the head of the data frame. I'm calling in row 2, column 3, and we get this value. So if we go down 2 rows, 1, 2, and we go over 3 columns, 1, 2, 3, we get this value, 30.36. Now, you look at that, that might seem a little bit arbitrary, right? Like, how do we know, like, if we have like a big data frame, how do we know like what column that we're actually specifying? And so you can actually specify, instead of column number, you can specify the column name. So again, I have the head of a data frame. I'm just going to call it ear diameter. So I'm going to call this column, and I specify that instead of a number, I specify that with text. And so I get this group of values. There's even one simpler way that we can do that in R, is through the $sign operator. So very similar to this, we can specify that column name from our data frame variable using a $sign. And so this should return the same thing, and it does. So again, we're just pulling out all the values from that ear diameter column. And now you notice we're starting to pull out groups of values, right? We're starting to pull out columns or groups of observations. And so this leads us to unfortunately, another piece of terminology. So this is, I think, the second piece of terminology that I brought up today, which is a vector. And so you notice that we have all these different functions that are returning groups of values, right? So I can get the dimensions, I can get the column names, I can get values for a particular column. So what we call these groups of values, we call that a vector, right? And you think of a vector, which is just 2 or more values that have a given sequence. So remember, this is like the order in the actual data frame. So this is observation 1, and then the last value is observation 20, and it has to follow that particular order. So the reason why I bring that up is because we just need some terminology for our next set of functions that we're going to be talking about. And yeah, and so like that, we can use a set of functions to analyze different vectors or groups of values. And this is kind of like the meat and bones of R, right? This is where a lot of like fundamental basis of our analyses come by, is by running analyses on these groups of numbers. So one thing that you may see, if you've never seen R, you look at mean, oh, that's probably going to give us an average. So how do we get an average? We get a group of numbers and we calculate the arithmetic mean. So we pull out that vector, we run an analysis, and we get an average value for that group of numbers as shown here. And this is also the fundamental basis for a lot of plotting functions as well, because when we're plotting data, we're plotting observations. And so R, straight out of the box, has a lot of just built-in nice visualization functions. So we have ear diameter. So now if we want to see the distribution of that, we can see numbers, but like, how do we show the actual distribution pattern of our data and start getting the inherent analyses from that? We can use things like hist, which is, if you've never seen that before, it might be a histogram. And so that's exactly what it does. It generates a histogram. And so we're just looking at the distribution here, albeit this is 20 values. So this, take this with a grain of salt. But, when you're doing this on your actual data where you have hundreds, if not thousands of observations, this will look a little bit more interesting. So yeah, that is the second part. And that kind of like leads into this breakout too. And since we only have 6 minutes left, I think this is going to have to be homework if you want to do this. And so I'll just briefly go over what that is, if you don't mind, Bethany. Yeah, so that's again here. And then we have this part 4 PDF, which is in the same location. So this is reviewing the data frame summary options. So head, tail, dimension, how does that differ between number of columns? How do we access data? So going over the square bracket and $ notation, accessing particular columns, analyzing data. So I have like a whole slew of functions that I just thought off the top of my head that you can play around with. So I have both like summary statistics here, but then I also have a lot of different visualization functions. And again, using that context component will really help with these actual visualization functions. And then I have like a little bonus round too, if you want to accomplish that in your free time, which is going over like the different components of plots. How do we make it more visually appealing? Also, start to do some like statistical analysis. Is there any correlation between this ear height value and this ear diameter value? So starting to get into the actual statistical portion of R. So are there any questions about that?